Welcome to an example in which we are looking to simplify and write this trig expression. It says in terms, terms of sine and cosine. Okay. So let me bring it down here for a second. So secant of t minus cosine of t over secant of t. I make my t's capital just so they don't look like pluses or something. Anyway, okay, how do we do it? Well, it says in terms of sines and cosines. So we got to say, oh, right. So we can do that. Come down here. We go. Okay. So the secant, so you need to know that secant is 1 over cosine. So those are on the notes. So secant is 1 over cosine. So therefore, and I'm just going to write C's and S's now. So I'm going to go this secant right here. I'm going to write 1 over cosine minus cosine. I'm going to get rid of the cosine, the t, just make it simple. And this secant down here, 1 over cosine. Just, once I change to sines and cosines, I like to just use C's and S's. Just makes it quicker and easier. I can put the other stuff back in, make it more formal at the end. Okay, now what do I do with this? So notice I've got fractions over fractions, right? What do we always do with fractions over fractions? Now you might think, well, we grab this guy and flip it up. Well, not when you got adding, subtracting. Let me write a note over here. So when you have fractions over fractions with adding, subtracting, that's what we're talking about. We have fractions over fractions with adding, subtracting, right? This guy right here is a big deal. Adding and subtracting glues things together. So you need to know this. You're going forward in math and science, physics, all these, calculus. We use this is really important. So pluses and minuses kind of like glue. They glue things together. They make those are separate terms glued together. So when you have that, what are you going to do? You have to multiply the top and the bottom by the LCD over 1, where the LCD equals 1 of each item under a small bar. The LCD is 1 of each item under a small bar. So this and this, those are the two items under small bars. Is that making sense what I'm saying? So we have, because you have the big bar here, and we have these little bars here, right? So the items under little bars, in this case, they're both the same thing. They're both C. And it says just one of them, 1 of each item under the small bar. 1 of each, maybe I should say 1 of each type of item under the small. So anyway, I'm just going to go C over 1, C over 1, C over 1. Does that make sense? I multiplied all the terms. I multiply the top and the bottom by LCD over 1, all the terms. All the terms, top and bottom. So C over 1, C over 1, C over 1. Now, that's okay to do because I'm doing the same thing to all the terms on the top and the bottom of the fraction. So I'm not changing the fraction, right? If you do the same thing to all the terms on the top and the bottom of a fraction, you have not changed it. You're just going to make it look different. I call it plastic surgery. We're going to give it a new look, remove the wrinkles, but it's going to be the same value it was before. It's going to be nicer and cleaner and no more fractions over fractions. So I'm doing the same thing on the top and the bottom. All the terms on the top and the bottom are getting the same treatment. So I'm not changing the value, which is important. That's what we do in math and science. We keep it the same, just looks different. Okay, what happens here? This C cancels that C, this C cancels that C. So what's left here? Well, that's just 1, right? 1 over 1 is just 1 minus. And what happens here? These C's multiply C squared, right? Because they don't cancel. You see that? You can't cancel. You can't cancel side by side. You can only cancel top and bottom. Like, and then these cancel right here as well. So this will just be 1 on the bottom. Do you see that? It's really important that you see that. So these C's cancel. Whoops, that colored highlight thing. These C's cancel. These C's cancel. These guys multiply. They multiply. Why? Because they're both in the top. Right? These C's are both in the top. So you really got to focus in on that top-bottom issue. That's really a big issue. These guys cancel because one's in the top, one's in the bottom. These guys cancel because one's in the top, one's in the bottom. These guys are both in the top. Right? That you think, what are you talking? This is C over 1. Any C alone is really C over 1. These are both in the top. That's going to be C squared. They multiply. Okay? Now, where does that leave us? Well, that leaves us with 1 minus C squared. That 1 on the bottom, you can just get rid of it, right? Dividing by 1 doesn't do anything. So get rid of that. So that's equal to 1 minus cosine squared of t. And that's our answer, right? Because they said to rewrite it in terms of sines and cosines. Oh, wait a minute. Oh, no, we can simplify a little bit more. Wait, one more step here. Simplify and write in terms of sines and cosines. So we can, there's one more thing. Do you know what 1 minus cosine squared equals? It's sine squared. That's our final answer. Well, where'd that come from? Well, if you remember in the notes, remember we have the formula sine squared plus cosine squared is 1. So if I was to subtract cosine squared from both sides, you get sine squared is 1 minus cosine squared. So when you see 1 minus cosine squared, that's the same as just sine squared. 1 minus cosine squared, that's just sine squared. So whenever we have 1 minus cosine squared or vice versa, 1 minus sine squared, we replace it. 1 minus cosine squared is just sine squared and vice versa on that. So that's all in the notes. Let me maybe worth it 1 second here at the end of the video to show you where that is in the notes. You want to use those during your homework and especially during the exam. Let me find them for you. This is the chapter 9. Oops. Trig identities. There it is. So copy it over and highlight it here for you. The notes, chapter 9. And you see right here, sine squared plus cosine squared is 1, and sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. You want to be looking for those all the time. So we had 1 minus cosine squared, which is equal to just sine squared. So 1 minus cosine squared is equal to sine squared. And so there we go.